Okay, so we're going to continue. It's another example like the one in the last part where you have the integral and you need to switch. So 0, 0, 0, 2, 1, and 1 minus y squared. And you also need to switch to dy dx and dz. Okay, so let's see what we have. We have z in multiples between 1 minus y squared and 0. So z multiple, we have 1 minus y squared and 0. We have y in terms of x, 1 and 0. So y in terms of x, 0 and 1, or 1 and 0. X numbers, 0, 2. X numbers, 0, 2. And you also need y multiple, x in terms of z, and z in terms of y. Now, to do, first of all, y in terms of multiple. So, from the main equation, z equals 1 minus y squared. You bring the y squared over 1 minus z, so y equals positive negative root. But since y is limited 0, 1, meaning that y is positive, so we're not going to take the negative root. So we're going to go this to a minimum 0. So we have 1 minus z squared to 0. So that's y in terms of multiple. Now we need x in terms of z. You'll see there is no equation for x in terms of z. So if there is no equation x in terms of z, nothing where you see x and z together, stick to the numbers. So whatever the numbers are, leave them. So that would be your limits for x, z, the numbers, whatever you have here. And finally, you need the z in terms of z. You can find the z from here or from here, doesn't matter. Y is 1 and 0, so if you plug 0 and 1, that gives you 1 and 0, so 0 and 1. So, making the switch for the function dy dx dz, y in terms of multiple, 0 and the root, x in terms of z, 0 and 2, and this is 0 and 1. Now this is it for this question. We go to question, if you notice I put root 1 minus z squared, it should say z only, so make the adjustment. I here have z squared, so change it to just z. Okay, we get into more complicated triple integral where we need to switch to polar system. So no longer this, it's switching to polar. So first question in switching the polar, z dv. So remember, you'll see the dv, and they tell you it's bounded by, again, x squared, y squared. That's an indication of radius. And xz, 3 and z0. Now, what you need to know, obviously, that dv is r dr d theta. Oh, dz dr d theta, sorry. Because it's involving z as well. So dz first, then dr d theta. Okay, so we need to integrate this, and we need to switch the limits. And the limits involved here, we need the r and we need the theta. So we need the r, we need theta, and we also need the other angle, so r dr d theta, so we need r and theta. So we start with this. We know x plus y squared is this, that means r squared is 4, radius is 2. So I integrate z, instead of dv, we go r dz dr d theta. I need the limits for z first. For r we know 0, 2, and for theta, complete circle. I need the limits for z. And the limits for z, let's have a look at what we have. We have z0 and this. So we have this and this. Well, z0, so that's easy. Here, z is 3 minus x, and in polar, that would be r cosine theta. So we go 3 minus r cosine theta. So it becomes pure integral. Z r dz integral would be z squared over 2. And you put the 3r cosine, and you put the 0. You put the limits first for this, so you need 3 minus r cosine theta squared times r over 2 minus 0. I'm going to erase some of this. So if you expand, 3 squared is 9 over 2, so 9 over 2 r. You multiply first by second by 2, would be negative 6 r cosine over 2 minus 3 r cosine over 2 would be 3, and times another r, so that becomes r squared. And finally, you square this, would be r squared cos squared times this would be r cubed cosine squared over 2. And then you still need to do this dr d theta 0 to complete circle. Integrating with r would be 9 over 4 r squared. Integrating this would be r cubed cosine theta. Integrating this would be r4 over 8 cosine squared theta, and we put the 0 and the 2. 0 to pi and d theta. You put the 2, gives you 9. You put the 2, gives you 8 cosine theta. You put the 2, would be 16 over 2, that's 2 cosine squared theta, and the 0 cancels everything. D theta, integrate 0 to pi. For the cosine squared, I can use half angle identity, and if you guys remember, that's 1 plus cosine 2 theta over 2. So I can replace this by 1 plus cosine 2 theta over 2. So it becomes 2 pi 9 8 cosine theta. If I put this here, the 2 cancels with the 2, I would only have 1 plus cosine 2 theta, all integral d theta. 9 plus 1 is 10, Integral of 10 is 10 theta. Integral of this would be a sine. And integral of this would be sine 2 theta over 2. I need to put the 2 pi and the 0. Put 2 pi here, gives you 20 pi. Sine of 2 pi is 0. Sine of 4 pi is 0, cancels, minus, put the 0, cancels. The answer would be 20 pi. Okay. Another question, triple integral involving switching to polar. So, root x squared plus y squared 2 minus 4 minus x squared 4 minus x squared minus 2 x squared y squared dz dy dx, and that would be dv. That's the same thing as saying dv. And we know, we told you, dv is r dz dr dz. So right away, I know this is r squared, and I know I can put r dz dr dz. I need an equation for z. Well, they tell me here z is 2 or z is this. z2, so that's 2, no problem. Z of this, if you switch to polar, that would be square root of r squared, that's r. So the limit here for the z is r. I need dr, and I told you so many times to figure out the radius, you look at the number. Radius is always the square root of the number. Radius is 2, you go 0, 2, complete circle. So the integral r cubed, so r cubed z, 2 and r, you put the 2, so that's 2r cubed minus r to the power 4. I'm integrating this, 0, 2. 2r cubed minus r4 dr d theta. That would be 2r4 over 4, r5 over 5, and you need 0, 2. If you plug 2, that would give you 8 minus 32 over 5 minus 0. And if you do the common denominator, that's like 8 over 5. Now that's what you're integrating. From 0 to 2 pi. 8 over 5 d theta, which is 8 over 5 theta, 2 pi and 0. Put the 2 pi, 16 pi over 5 minus 0. The answer is 16 pi over 5. This is when you switch to polar. There is another switch to polar. I'm hoping that he doesn't ask in the exam. But again, if he does, it's not that bad. It's polar 3D. I'll tell you the equations. Radius would be, they call the radius P, and it's x squared plus y squared plus z squared. You also need to know that dv for polar 3D, I'll put it here, polar 3D, is p squared sine phi dp d phi d theta, or we call it angle 1, angle 2. And how do you know that the question is 3D? You see the question here, integrate e, you see x squared, y squared, but z squared also. So that's an integration, an indication of 3D. And dv, and they tell you it's unit sphere 1. Okay, from this, p squared is 1, p is 1. So if I integrate this, watch. This is p squared. I still need to raise it to 3 over 2. Instead of dv, we go p squared sine phi dp d phi d theta. Now, the limits, first limits are for dp. Since the radius is 1, so 0, 1. 5. Since they tell you it's unit sphere in the question, so you're only looking at the 1 unit, so it would be 0 to pi, because it's a unit sphere. And theta is always constant to pi. So you're integrating 0, 1, 0 pi, 0 2 pi. When you raise to multiple exponents, you cancel, so it's p cubed, p squared, sine phi, dp, d phi, d theta. We've seen something similar to this. This is the function. It looks like it's derivative. Hide the derivative. Integral of e is itself, but there is a 3 extra, so over 3. Sine of phi dp, we did the dp, we don't need to do it again. This is from 0, 1, d phi, d theta, and we have 0 pi, 0 2 pi still. We plug 1, it would be e over 3 sine. You plug 0, it would be 1 over 3 sine. Or basically, it's e minus 1 over 3 sine, d phi, d theta, and it's 0 pi, 0 2 pi. Okay, the integration of sine would be minus cosine, so minus cosine, which is minus of this, cosine theta, cosine phi, and we put pi and 0, and we're still integrating the result from 0 to pi. You put the pi, cosine pi is minus 1. And a minus becomes positive. You put the 0, cosine 0 is 1, so you have minus of e minus 1 over 3. But minus minus becomes positive, so you just add these two. If you add them, it will give you 2 of e minus 1 over 3. That's what you're integrating 0 to pi. D theta. Integral of this obviously would be the constant theta and 0 to pi. Plug the 2 pi, gives you 4 pi over 3 the 2 pi e minus 1 minus 0, so that's a final answer. This is the answer for triple integrals. Now, there is another example we're going to do for triple integrals, 3D polar, but I'm going to do this in the next part.